Hello, welcome back. After introducing the relational data model, its components and its importance within a management information system, we will now discuss the issues of redundancy and inconsistency, and how a technique called normalization can help us in this regard. We will also analyze how application programs interact with the database management system through sets of commands such as SQL, and how this explains why some packaged management information systems support several alternative database management systems. When the same piece of data or attribute in our terminology, for example, the address of a customer, is stored in more than one place, this is called redundancy. The main problem with redundancy is that it might lead to inconsistency. If the customer's address changes and it is stored in more than one place, this might lead to the same attribute taking two different inconsistent values. Inconsistent data can be a major issue for corporations. For example, inconsistency in product codes might lead to a customer ordering one product and being delivered a different one. Inconsistencies might occur at different levels. Different management information systems might contain inconsistent data, and we will deal with that issue later on in this course. Besides, a given management information system might contain inconsistencies within its own database. To avoid this undesirable situation, while creating a relational data model, we will apply normalization techniques. The normalization process leads to databases where redundancy has been eliminated. It should be remembered, however, that whenever data is stored in more than one system, for example, if we download data from our corporate information system into our PC to carry out some analysis, there is a potential risk of data inconsistency. Going back to the simplified model of a management information system discussed in previous videos, differentiating specialized application programs, the database management system, and the database itself, we'll now analyze how application programs interact with the database through the database management system. As you will recall in our garage analogy, car owners did not need to interact directly with the spare parts storeroom manager. They would take their car to the specialized mechanics that, whenever needed, would ask the storeroom manager for the required spare parts. Going through the storeroom manager makes life easier for the mechanics. They do not need to know the precise details of the racks and shelves in the room. Furthermore, the storeroom manager takes care of things such as setting up a queue if several mechanics come asking for spare parts at the same time, or validating and logging spare parts requests. The database management system also simplifies the development of the specialized application programs. They do not need to worry about the details of how data is physically stored in the databases. Besides, they can focus on their specialized tasks, such as accounting for transactions, and leave it up to the database management system to carry out all data management related tasks. To illustrate this, let us look at the concept of a database transaction. If an application program in a banking information system wants to transfer some funds from one bank account to another, it must reduce the balance in one account and increase it in the other. It would, however, be unacceptable if, due to some sort of interruption, it were to reduce the balance in the first account, but not to increase it in the second. Either both changes are made to the database or none of them is. Those two changes make up a transaction. Information systems must somehow guarantee that either all changes within the transaction are successfully completed, or if something fails, all previous operations are rolled back or cancelled. Fortunately for application developers, they do not need to worry about the complex details of implementing this. The application program simply informs the database management system of when a transaction starts. Then spells out the various operations included in the transaction, and Once it finishes, it sends to the database management system a commit instruction to write the operations in the database. If the database management system, for whatever reason, does not get a valid commit, it will automatically roll back. Thus, we have discussed how a database management system relieves application programs from generic data management cores. That requires, however, establishing how application programs will interact with the database management system. We shall analyze that in the next video. Thank you. I will see you there.